Natural numbers. Learning intention. Use place value to build, order, and compare numbers made from given digits. Success criteria. I can make the largest and smallest number using each digit once. I can list different numbers from the given digits with no repeats. I can put the numbers in ascending or descending order. I can find the difference between two numbers. I can explain my choices using place value. The counting numbers 1, 2, 3, 4, 5, ... are generally called natural numbers. We use the capital N to represent these numbers. Thus, N is equal to 1, 2, 3, 4, 5, 6, ... These numbers go on and on forever. There is no end number. So N is equal to 1, 2, 3, 4, 5, 6, ... 0 is not a natural number. So the official definition for natural numbers is positive whole numbers. So negative numbers are not natural numbers. Fractions are not natural numbers. Decimals are not natural numbers. Natural numbers are positive whole numbers. And the first natural number is 1. The number line. A very useful and simple way of depicting natural numbers is to place them at equal distances apart on a horizontal line as illustrated below. So here is our number line. So 1 is our first number and we have a dot over the 1. So 1 is the lowest natural number. Then we have 2, 3, 4, 5, 6, and 7. And very important, we have an arrow to the right to indicate that the natural numbers go on forever. So 8, 9, 10, 11, 12, ... on and on forever to infinity. The dots on the line represent the numbers 1, 2, 3, 4, ... while the arrow to the right indicates that the line continues on without ending. Notice that there's no arrow on the left-hand side, and that's because 1 is the lowest natural number. It's the first natural number. So it wouldn't make sense to have an arrow to the left of that because 0 is not included. Place value. The symbols 2, 3, 5, 8, etc. that we use to represent numbers are called numerals. In our number system, we can write any number, large or small, using the 10 numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So every single number that we have is made up of some or more of these numbers. The big advantage of the system is that the same numeral may have different values depending on the place it occupies in the number. The place value diagram below shows the numbers 368 and 26,427. So we see in blue we have the 10,000s, in green we have the thousands, in lighter green we have hundreds, in yellow we have tens, and in orange we have units. So here 6 means 6 tens, which is equal to 60. So this 6 here in the number 368 represents 6 tens, which is 60. Whereas here, the 6 represents something else. Here, the 6 means 6 thousands, which is 6,000. So in the number 26,427, the 6 represents 6 thousands. So the two 6s in these two examples, they have very different values. 60 and 6,000 are very different numbers and they're not close to each other on the number line. The numeral 6 has a different value in each of the numbers as shown above. So place value is very, very, very important. Example 1. Find the difference between the largest and smallest numbers that can be made from the digits 3, 7, 4, 9 if each is used once only in the number. So the largest number that we can make with those 4 digits is 9743. So going in order from largest to smallest, we have 9743. I have commas at the moment, but when I actually try to work this sum out, I will take away the commas, but I just have them in at the moment to indicate that they're going from largest to smallest. Going from smallest to largest, we have 3, 4, 7, and 9. So they're just rearranged now in the opposite way. So we want to find the difference, so we're going to subtract. So I'll take away my commas now. And if you input into the calculator 9,743 minus 3,479, you will be left with 6,264. So you are allowed to use your calculator in your Junior Cert exam, so I would suggest that you get practice using it now. But if you want to know how to do this, the long method, we'll have a look at that now. So the difference is 6,264, so we're just going to double check. So we want to do 3 minus 9, which we cannot do because 9 is bigger than 3. So we're going to have to borrow a 10 from the 4. So the 4 becomes 3 and the 3 becomes 13. So 13 take away 9 leaves us with 4. So then we want to do 4 minus 7, but we can't do that. So we're going to have to borrow from the 7. So the 7 becomes 6. And we stick a 1 in front of the 3 that was left over from when we borrowed already. So 13 minus 7 gives us 6. Next, we can do 6 take away 4. We don't need to borrow. 6 minus 4 is 2. And we can also do 9 minus 3. We don't need to borrow. There's nowhere to borrow from anyway. So 9 minus 3 is 6. So double checking, it is 6,264. Example 2, using all of the digits 3, 7, 2, write down 6 different 3-digit numbers in descending order. So descending order means going from largest to smallest. So the first number that we can create is 732. So this is the biggest number we can create with the digits 3, 7, and 2. The next biggest number is 723. Then 372 is the next smallest. Then 327, and we keep getting smaller, 273, and finally 237. So now what we've done is we have arranged the digits 3, 7, and 2 in all the different ways that we can to create 3-digit numbers, and they're going in descending order. So they're going from largest to smallest.